Hello everyone, my name is Raghavendra Ramachandra. I am from Norwegian University of Science and Technology, Norway. So in this work, we are trying to introduce for the first time the multispectral imaging for face morphing attack detections. So more particularly, we are looking for differential based face morph attack detection. That meaning that, so given the two face images, we need to identify one of them as an morphing or as an bona fide. So outline of my presentation is as follows. So I will start with a quick introduction on the face recognition systems and its application and the vulnerabilities on the face recognition systems, which is then followed by the research contributions that we are trying to address with this paper. And we have a proposed method and we have experimental results, and finally we draw some of the conclusions. So as we all know that the face biometrics are widely deployed in various security related applications that includes the person identification, smartphone access, banking, border control, and finance applications, and so on and so forth. And today the face biometrics has become an integral part of our everyday life because we are using the face recognition systems for more than a decade on our smartphone. The face biometrics in border control is prominently used. Following the ECOW standard, the face has been identified as one of the primary identifier that need to be used within the ePassport. ePassport is also called as EMRTT device. So this is a document where our face images are stored in the digital format in the chip. So as of today, so more than 800 million passports that are deployed with the face biometrics that are widely used by the owners of the passport whenever they want to do the border control checks, especially crossing the borders using automatic border control gate. So as the face recognition systems are widely deployed in the various applications, the vulnerability of the face recognition systems are also being getting more and more popular. So starting from the different types of attacks, for example, there are the direct attacks. That means that the face recognition systems can be directly attacked at the point at which the face images are captured. So direct attacks is nothing but the attack on the sensors that are used to capture the face biometrics. There are several types of direct attacks. One can fabricate an attack by using different kind of biometric facial biometric artifacts. So these artifacts, for example, include a facial mask or the print attack or the electronic screen attack and so on and so forth at the direct attacks. Similarly, some of the attacks that are getting more popular nowadays is the adversarial attacks where we can trick the face recognition system to not to verify the particular data subject, and also the use of makeup attacks to impersonate ourselves from getting verified, and also like making up like someone else. We can also trick the face recognition system to think face recognition system to verify us as in someone else. So among these makeup attacks and presentation attacks and adversarial attacks, so one of the another type of attack that is getting more popular from past 7 to 8 years is the morphing attacks. The morphing attack is a process of combining two images. So given the bona fide images, for example in the right top corner of the figure, so given the two bona fide images, there exist several techniques that can generate the morphing attack. So idea of the morphing is like that it's a process of blending two images to generate the one resultant image. That image must have an visual characteristics of both images that are used to generate the morphing. So depending upon the type of the technique, we have non-deep learning based techniques and the deep learning based techniques. So for example, the use of simple landmark based techniques which are publicly available in the OpenCV is is one such example where one can easily generate the morphing image, and the use of this morphing image against the face recognition system can generate a multiple verification for both the bona fide subjects which are used to generate this morphing image. That means that, for example, if someone is using a morph image to get their passport, obviously the persons or the data subjects who are involved, or the face images of the data subjects that are used to generate the resulting morph image can get verified equally well when the morph images get enrolled to the face recognition system. So this means that if the attacker can get the passport with morph image, then he can easily use that passport to automatically cross the border. So there are two different ways how the morph attack detection can be performed. The first type is on the single image based morph attack detection. The application scenario is the passport application scenario. So where it can be used, this means that so given a single facial image, so we need to detect whether it is a morphed image or not. So in case of the differential morph attack detection, which is also a scope of this paper, so we try to use more than one image. So first image is from the passport, and the second image is from the automatic border control gate. That means that the second image what we're using from ABC gates is the trusted device, and while the face image in the passport is the questionable. That means that whether it is a bona fide image or it may be a morphed image. By having the reference from the trusted capture, that is the ABC capture, our goal is to identify whether the image within the passport is morphed or not. So there exist several techniques for both single image based techniques as well as the differential image based MAD. But all these existing techniques that are available today is for the visible spectrum. That means that given the RGB image, and the border gate is also capturing the RGB image, and then the DMAT techniques are devised to work within the RGB image. So in this work, our goal is to see, or is to investigate what if the ABC gate can capture a multispectral imaging. In the scope of this paper, the multispectral imaging means that we are going to capture multiple bands within the both visible and one band in the near infrared, to see whether having these multiple bands of capture within the visible spectrum may be an useful to, or maybe an helpful to effectively detect the differential morph attack scenarios. So to this extent, we formed three different questions. The one is to investigate what are the individual spectral bands that may indicate the highest morphing detection accuracy, and also the second question is answering about like how the individual spectral band performance compared with the visible band, and the third question is about utilizing the complementary information that is available in the multispectral capture, and if we fuse those complementary information, does the use of multispectral ABC in the DMAT scenario is giving better results than visible image alone. So with these three questions in the back, three questions in the mind, so we propose the framework. So our framework is, the only difference here compared to the existing work is we are bringing in the notion of multispectral here. So here in this work, within the scope of this work, we are investigating the spectral bands from 650 nanometers to 950 nanometers, and we also have a whole light image. The whole light image is not with any filters. So the camera is sensitive from visible light to near infrared light, so that we get one single image that can reflect the characteristics across both visible and near infrared. With this multiple band, and we have an RGB image from the passport, our idea is to see how the existing DMAT techniques will work under this scenario. So to this extent, we have developed a new database which is also publicly available. The link for the database is also available in the paper. So within the scope of this work, we have developed a new database of 140 subjects, close to 140 subjects. We have captured the visible image using DSLR cameras, which is high quality image reflecting the real life enrollment scenario for the passport, and also the multispectral images are captured with the high quality without any reflections or shadows on the face that can capture the ABC scenarios. And for the morphing generation, we used one non-deep learning based and one deep learning based technique, and in the non-deep learning based technique we use the open source landmark available in the OpenCV, and for the deep learning based we use the open source from the that are available in the GitHub named as MIPGAN 2. And then we run series of experiment, but for the small duration of this presentation, I'm just presenting one result. So where we clearly show that irrespective of the morphing generation type, the use of multispectral for DMAT detection will provide an excellent improvement of performance over visible band. So with this, I would like to end my presentation. Please do drop by my poster, so that we can have a very detailed discussion on what we have achieved. So the conclusion is the use of multispectral in the DMAT scenario has bring a very good performance improvement compared to the visible spectrum. Thank you.